So for number 4, this is the function and on the interval -3 to 1. So the question said, does it satisfy the hypotheses for mean value theorem? Yes or no? If it's yes, do the problem. If it's no, then state why not. And so this one is no, and that part went well. And then explaining why not. For mean value theorem, the function has to be continuous and differentiable. So the issue with this one, it's absolute value, there's a sharp edge. It is not differentiable at x equals -2 due to a sharp edge. And so the only thing is, most people wrote sharp edge, but you have to mention these two things as well. Differentiable is the important vocabulary word there. It's the function has to be continuous and differentiable. So you have to mention that it's not differentiable. And then the location of the problem is really crucial too, because -2 is on this interval. That's why it's an issue. If the interval was somewhere else, like say it was 0 to 7, -2 wouldn't even be on the interval, and then the answer would be yes. So this location of that is just really, really important. So you do need to mention that too. But that was the only one I wanted to make sure I definitely went over. I'll take your questions for a few minutes as well. So if you guys want to type them in the chat, is there another one that you guys would like to look at together? All right, so for number 5, this is the function, and we're not on an interval, just that function, and it says find a coordinate point x, y, so we want the whole coordinate point, and state whether it is a relative maximum or a relative minimum. So we're going to start with getting the critical points. So it's derivative equals 0. So e to the x exponential is its own derivative, and then derivative of x would just be 1. 2 is a constant, so that's going to go away. So derivative equals 0. We're going to add over the 1. And then to cancel out e, we're going to do ln. So that gives us x equals ln of 1 is 0. And so that is our critical point, x equals 0. So we need to make a number line to show whether this is where we have a maximum or a minimum. So here's my derivative, e to the x minus 1. And so we're going to make a number line for that. So I'm going to test a point over here. If we test -1, e to the -1, I don't know what that is as a decimal just off the top of my head with no calculator, but e to the -1 is going to be 1 over e. The negative exponent reciprocates it. And then we'll have this minus 1. So e is about 2.7. If you even want to round that to 3, this is just whether this is positive or negative. You don't need to figure it out exactly. Pretend e is 3. We'll just round. This would be 1/3 minus 1, which is negative. So you don't need to figure out the exact value. You're just picking a test number to see whether it comes out positive or negative. And then if we pick a number over here, I'm going to try 1. E to the 1 is just e, and then minus 1. So again, if you want to round that to 3, e is about 2.7. 2.7 minus 1 is going to be a positive result. And so we got that the derivative changes from negative to positive. So hey guys, negative to positive means relative what? What is our final conclusion of the whole thing going to be here? Relative maximum or minimum? Good, nice job guys. Minimum, negative to positive means minimum. So relative minimum is, and I asked for the whole point. So we're going to have to take 0, that was our x value, plug it back into this original function. So e to the 0 is 1, then minus 0 plus 2. So that is going to give you 3 for the output there. So this is your final answer. Relative minimum is 0, 3. You're welcome. So would you guys like to pick another one? All right. So it is a direct message to me, so you guys can't see it, but 7C and E. So to get to part C, you need A and B. So when you do part A, your critical points come out to 0 and 1. And when you do part B, your number lines end up looking like this. I have to write these out because I can't do part C without it. So these are your answers to part A and B. So for part C, we're going to write a sentence for 0 and 1, relative maximum, minimum, or neither, and then a reason why. So at 0, we have a change negative to positive. That's the same thing that happened here, so that means relative minimum. So f of x has a relative minimum at x equals 0 because derivative changes from negative to positive there. And then at 1, we don't have a change. It stays positive. So f of x has neither a relative maximum or minimum at x equals 1 because the derivative does not change sign there. All right, and then I need part D in order to do part E. So for part D, you get the second derivative. You would get 1/3 and 1 for your inflection points, and your number lines would look like this. So I had to write that out in order to do part D, or in order to do part E. So for part E, we're writing sentences about concavity. So f of x is concave up on these two sections. So negative infinity to 1/3, union 1 to infinity, because the second derivative is positive there. And then f of x is concave down 1/3 to 1 because the second derivative is negative there.